Go on to question 5, which is a projectiles question, and we've got two balls which are being fired from 50 metres away from each other in opposing directions. We're given the information on the diagram. Ball P is being fired at 20 metres per second at an angle of 30 degrees, and Q is being fired at an unknown velocity at an unknown angle. Question comes in two parts. The first is to find out the velocity of A just before it collides with B, and the second is to find these bits of information about B. We know that they collide at the time t equals 2, so let's just give ourselves a note that t equals 2 at collision. So let's start looking at part A of the question then. What we're going to need to do is to resolve them vertically and horizontally, as is standard in these projectile questions, and we're going to look at the vertical components first. Okay, so we're going to just write down our suvat. Now, we don't know S. We do know U. U is the initial velocity. We're looking in the vertical plane, so it's going to be this component, it's going to be that component, which is going to be 20 sine 30. Sine 30 is a half, so it's going to be 10. V is question mark. It's what we're trying to find. A is minus 9.8, and T is 2. And so we can use our equation V equals U plus AT equals 10 minus 9.8 times 2, which is 10 minus 19.6, which is minus 9.6 meters per second. So as at time t equals 2 seconds, it's going downwards at 9.6 meters per second. We're going to resolve it horizontally as well. Now I would just use, when I'm looking at horizontal, I would just use distance equals speed times time, because your acceleration is 0. So my velocity is actually going to remain unchanged from what it was at the outset, which is going to be, so velocity, so U is equal to 20 cos 30, which is 20 times root 3 on 2, which is 10 root 3 meters per second. Because I could set it out in exactly the same way, but because A is 0, V and U are going to be exactly the same. So then I want to know, that gives me my velocity. It's so velocity is minus 9.6. Sorry, it's 10 root 3 I minus 9.6 J, if we're using I and J as our horizontal and vertical components. Notice it asks for the velocity, not the magnitude of the velocity, so once I've done that, that's me finished. So for part B, what I'm going to need to do is to find the position of ball A after time t equals 2 seconds, and then use that to work out what U and theta must be over here. So let's firstly look at particle A. At time t equals 2 seconds, we're going to find out what S is. S is question mark. U equals 10. V we're not interested in. A equals minus 9.8. T equals 2. So S is going to be UT, which is 20, minus a half times 9.8, so minus 4.9 times 2 squared. So that's going to be 20 minus 19.6, which is 0.4 meters. So they're going to collide 0.4 meters above ground level, and looking horizontally, we're going to say that distance equals speed times time. So distance, this is my horizontal side, distance equals speed, which was 10 root 3, times by 2, which is 20 root 3. if I want that as a decimal, I can also work it out as a decimal. 20 root 3, which is 34.6 meters. Okay, this is going to help us. So we know that what's happening, going back to my original diagram, is particle A is going to be coming up here, and somewhere around here it's going to be 0.4 meters above the ground at a distance of 34.6 meters. While this one comes out here and it's going to be 50 minus 34.6, which is going to be, I've got 15.4 meters here. So the way I'm going to do this now is I'm going to move over onto B, and what I want to do is I know that it takes 2 seconds to reach a height of 0.4 meters. So let's look at particle B. I know that S is equal to 0.4 meters. U is actually equal to, if I'm resolving vertically, U equals U sine theta. V I'm not interested in. A equals minus 9.8 and T equals 2. So I can now say that 0.4 equals U sine theta times 2 minus 4.9 times 4. So that's going to give me 19.6. So I end up with U sine theta equals 10. Resolving horizontally, I know that the speed is U cos theta times 2 must give me my 15.4 meters. So I've got 2U cos theta equals 15.4. So U cos theta equals 7.8. Now, what I should have done here is really have used my accurate answer from back here, so I should have used the memory function of my calculator. I've still got that as my exact answer, so I'm going to do 50 minus my answer before, which is going to give me this distance, and I'm going to divide that by 2, and that gives me my, in fact it's the exact answer there is 7.7 meters. It's the importance here of keeping distances to an appropriate degree of accuracy. So U cos theta equals 7.7, U sine theta equals 10. What I'm going to do is I'm just going to divide the two equations. U sine theta divided by U cos theta gives me tan theta. So tan theta equals 10 over 7.7. So 10 divided by my answer is 1.30. Tells me that theta is the inverse tan of 1.30, which is 52.5 degrees. I'm then going to use my fact that U sine theta equals 10. So I'm going to sine my answer and do 10 divided by that, and that should give me my U, which is 12.6 meters per second. In terms of the last question there, the thing that could affect accuracy of answer, there's a couple of different things you could put. You could have put the fact that because they're modelled as particles, it means they've got no dimensions. I think that's the biggest issue, because in reality they would have some dimensions. You could, for example, have put wind as a problem. You could have put turning forces as an issue. There's a bunch of different things that could go in there. But I think having dimensions and the fact that this models it as having no dimensions at all causes you your biggest issues.